Welcome to another awesomely radical edition of Comet Algebra. This video is for Algebra 1, Chapter 11, Section 5, Adding and Subtracting Radicals. Now this really follows everything you've learned so far in algebra, that you can only add and subtract like terms. How long have I been telling you that? So the same thing is true with radicals. You can only add and subtract radicals that are exactly alike. That means that they have the same root, meaning a square root, cube root, fourth root. So the root has to be the same, and the same number has to be under the root. So the steps you'll follow when you're adding and subtracting, first you want to simplify the radicals because sometimes you can't tell if they're like terms when they're not simplified. After you simplify them, you look them over, and anything that is alike, you go ahead and do the adding or subtracting on them. So let's look at a couple examples. Looking over example 1, it doesn't look like there's anything we can do with adding and subtracting because none of these are alike. So let's do that step 1 first. Let's simplify. And you can either make a factor tree for 45, or perhaps you've already noticed that 45 is the same as 9 times 5. 9 being the perfect square of 3, so the 3 comes out in front. So that simplified is 3 square root 5. Now moving on to the 18, if you can make a factor tree if you like, or you can recognize that 18 is 9 times 2. The square root of 9, I've got to remember my plus sign, is 3, so the 3 comes out in front, the 2 is left behind under the radical. And then we're subtracting a square root of 5, which cannot be simplified. So now I just scan through and look what I have. This is a square root 5 term, and this is a square root 5 term. So those two can be added, or in this case, subtracted. So 3 square root of 5 minus 1 square root of 5 is 2 square roots of 5. And this square root of 2 term cannot be combined with anything, no like terms, so that is my simplified answer. All right, looking through example number 2 here, nothing to simplify with this square root 2, nothing to simplify with this cube root of 2, and still nothing to simplify. But this example illustrates the point that you can only add if they have the same root and the same number under the root. So this cube root of 2, I don't have any other cube roots of 2, so there's nothing to combine with that. But here is 1 square root of 2 minus 2 square root of 2. Those I can combine. And that would be a negative 1 or just a negative square root 2. And then I'm still just adding this cube root 2, and those cannot be combined, so that is the simplified answer. All right, looking at example 3, I'm noticing I have a mix again of cube root and square root, so please be careful what you can and what you can't add. Nothing to simplify, but 1 cube root of 2 plus 4 cube roots of 2 would be 5 cube roots of 2. And then, a negative square root 6 and a positive square root 6 is nothing, so this is the simplified answer. Looking at example 4, once again, clearly we have to simplify first because we simply can't tell if there's any like terms here. So you could do the factor tree for 98 if that's what you prefer. I happen to notice that 98 is 49 times 2. Square root of 49 is 7, so this simplifies to 7 square root 2. 27 is 9 times 3, so that simplifies to 3 square root 3. 50 is 25 times 2, so that simplifies to, and notice the subtract sign, minus 5 square root of 2. And this last term doesn't need simplifying, and now we just look and see what we have. We can combine the square root 2 terms. 7 take away 5 is 2, so I have 2 square root of 2. And 3 square root of 3 plus 1 square root of 3 is a positive 4 square root of 3. So that's our simplified answer. And in example 5, of course, we have to have some with the x's and y's in it. Looking here for something to simplify. These first two terms look okay, but this 405 definitely needs some simplifying. I don't see any perfect squares, so I'm going to have to go to a factor tree. Dividing 405 by 5, I get 81. Oh, and there it is. There's the perfect square of 9 times 9. So this x squared at 5 is fine. The 3 squared at 2 is fine. But this 81, square root of 81 is 9, so let's pull the 9 out in front. And I hope you noticed that x squared is a perfect square, so we got to pull the x out also. And all that remains behind under the radical is this 5. So now looking for things to combine. Here is an x square root 5 term, and here's an x square root 5 term, so those can be combined. One of them plus 9 of them is 10 of them, just like 1x plus 9x is 10x, so this follows everything that you've learned so far in algebra. But these two terms are not alike and cannot be combined, so we are done. That's the simplified answer. All right, now you have the knowledge you need to do section 11.5, so have a radical time with that.